This video is for lesson 2.7, which is solving multi-step equations. And just as it sounds like it's just more steps than what we've done. So what we've done the last few days is a lot of the same things, but you could maybe do it in 2 steps. And now it might be 3, 4, 5, 6, and so on. There's also going to be some distributing. There's some combining like terms. Another big difference is that now where maybe used to be where something was already alone on one side of the equation, here we've got things to simplify on both sides of the equation. Sometimes you have a decision to make, like which side you actually want to clear out. And as we'll see, it doesn't really matter. You can make a choice and either way it should work. So on the first one, it might actually show 2 different ways to do that, just to demonstrate that it doesn't really matter. For the other ones, I think I'll just show one way or another for the sake of time, but just so you are aware. So on number 2, and this time I wrote the page number of your assignment, and these are the numbers of the problems that you are asked to do for your assignment. And notice that for each of the examples, I picked something that was like very close to it. So it's gonna be a very similar type of problem. So on this one, I'm gonna draw my line down the middle, separate that. So first thing we'll look, can I simplify anything on either side? I can't here. I don't have any like terms on either side. So I can decide, do I want to get x alone on the left-hand side or x alone on the right-hand side? And this time I'm going to try it on the left-hand side. So right now I've got 7x. I want to get the x alone. And right now it's being multiplied by 7. And we're subtracting 20 from it. And again, I said this in other videos, we kind of like to do this in reverse order of operations. So we want to deal with adding and subtracting first. So I'm going to undo that minus 20 by doing a plus 20 to both sides. And notice I'm only going to do it one time on each side. I'm not doing it under every single term. And that's part of the reason why I draw this line down here, is so we just remember we do it once each side. I am going to put it underneath the term that it will go with, though. So I can add the 20 to the 25. I can't really add it to the 2x. So I'm going to line it up with the like term, the thing I can actually combine it with. So minus 20 and plus 20, those are going to cancel out. I'm left with 7x. On the right-hand side, the 2x is still just 2x. And 25 plus 20 should give me 45. And it was all positive, so it's just plus 45. Now, normally, like previous problems, you might have seen, all right, we're at 7x. I need to now divide by 7. And I could do that, but it's going to just make more work for me instead. So what I'd like to do instead is I don't really want to have x on both sides. So since I would like to have x over here, I don't want to have on the right side. So I'm just going to try and get rid of, I've got 2 x's over here. So I want to get rid of the 2 and the x. So like in other cases, we maybe would have divided by 2, but I want to not just get rid of 2, I want to get rid of the 2 and the x. So I'm going to subtract 2x from here, and that's going to make it just go away from this right side completely. And just as usual, whatever I do to one side of the equation, I do to the other. So I'm going to do minus 2x here. Now, I actually could have done the minus 2x first before I did that plus 20. It's not really going to make a difference in the end, but I could have done either way. Oops, I didn't really know. So if I do a minus 2, I had 2x minus 2x. These are just gone. I didn't really need that equal sign there. I'm not sure why I put that, but I still have the 45 though. So I'm going to bring the 45 left down. I had 7x minus 2x, which should leave 5 x's remaining. So now this is good news. I have x on only one side of the equation, which is what we want, but it's not alone yet on this side. So it's being multiplied by 5, do the inverse operation, which is to divide by 5. If I do it to the left side, do it to the right side. 5 divided by 5 is 1. 1x is just x. 45 divided by 5, x equals 9. So a few things that we're looking for in these problems is, one, simplify each side if we can. This time there was nothing to simplify. And then you want to have your x on just one side or the other, which we actually did in our second step. I could have done that first. And then once you have it on one side, there, be sure that x is the only thing over there. So we divide by 5 at the end. So we had only an x. And we can check this answer real quick. We said x is 9. Well, 7 times 9 is 63. 63 minus 20 is 43 on the left side. On the right side, x is 9. 2 times 9 is 18. 18 plus 25 is also 43. So that checks out for us. All right, I'm going to clear this, and this time I'm going to show what if I solved it and got x on the other side, just to show that you can do it either way. All right, so this time I'm going to say, well, I want my x's on the right side to the left side. So this time I'm actually just get rid of the 7x right away. So I want to get rid of the whole thing. So I'm just going to do minus 7x. Because right now, if I don't see a sign, I assume it's positive. I'll get rid of it by doing a minus. And I'll do that to both sides. So over here, positive 7x, negative 7x, or minus 7x, all that I'm left with is that minus 20, or I could think of that as a negative 20 either way. Over here, I had 2x minus 7x. That's going to leave me with negative 5x's. And the plus 25 is still here. All right, so now I don't want to have all this stuff over here with the x, so at this point, I'm going to get rid of that plus 25. So I'm trying to clear out the right side, get x alone. I'm going to get rid of a plus 25 by doing a minus 25. I'll do it to both sides. These just cancel out. I'm left with just the negative 5x. Don't forget that negative. That's the thing where people can easily get tripped up if you forget to bring those signs down. Negative 20 minus 25 will give us a negative 45. All right, so I still need to get x alone. Right now it's being multiplied by negative 5. I'm going to do the inverse operation. I'm going to divide by a negative 5. And if it's negative, to undo it, I need to use a negative again. So divide both sides by negative 5. Negative 5 divided by negative 5 is 1. 1x is just x. Negative 45 divided by negative 5 is a positive 9. So as you'll see, I got the same answer I did the first time. Things just got flipped around a little bit. So where we've sometimes had negatives before, we had positives. But in the end, we came up with the same answer. So it doesn't really matter which side. If you've got the variable on either side, you can really choose which one you'd rather clear out. All right, so on to number 10. So first step, I just want to simplify each side, combine like terms if I can. On the right side, there's nothing that can be combined. On the left side, I've got b's and more b's, so I can combine these. I have 82 b's, I'm taking away 9 of them. So that should give me 73 b's. Plus the 7. Once again, I'm just using my mouse on this. It makes it slower and sloppier, but I still haven't come up with a better way yet to do this. All right, so this right side, I just rewrote it because nothing could be simplified on that side. So already something looks a little bit strange to me. If I've got the same amount of b's on each side, and we're saying they're equal, but one is being added to 7, the other one is being added to 19. I'm going to still continue as if I was solving this regularly, but already that's telling me that something's not right. So let's say though that I wanted to clear out the left side. So I've got that plus 7, I'm going to do a minus 7. And I'm going to do the minus 7 here because it's the 7, because I want to line it up with like terms. So these just drop out. I'm left with my 73b. On the other side, I've got 73, oops, undo that, 73b. 19 minus 7 should give me a positive 12. So I can't think of any number where I can have 73 of this and 73 of this, and I add 12 and I actually get the same value. If I did want to clear it out on each side, so I only want b on one side or the other, like I said, I'm going to take away the 73b on this side so that I don't have any more b's over here. Do the same thing over here. So those are gone. These are gone. There's nothing left on the left-hand side, so I just have 0. 0 equals 12. I'm pretty sure that's not true. So this would actually be what we would call a no solution. It means it isn't actually possible that you could find anything for B that would make this a true statement. And honestly, back at this point, when I first simplified, I already could tell like this isn't going to make sense. I can't take two of the same thing, add to 7 to one of them, add 19 together and get the same answer. But I went through the other steps anyway, just to kind of show you get to the end and you have something like 0 equals 7 or 0 equals 12, means there's no solution. All right, moving on. So they're getting a little more complicated, same type of things, just more steps. So I've got some distribution to do in this one. So first step I'm going to do is, if I could combine the terms in the groups, I would, but I can't because they're not like terms. So I will just distribute instead. I draw these little arrows just to remind myself that I am multiplying this number on the outside of the parentheses times each of the values inside the parentheses. 8 times 2t should give me 16t. I assume this is a positive 8. A positive 8 times a positive 1 will give me positive 8. Now this next one, what can be helpful is just think of this. If you don't see a number in front of there, just assume it's a 1. So you can think of a negative 1 times t, negative 1 times negative 9. Because this is where we're multiplying, where we have this negative in front of a set of parentheses is where I see some of the most common errors is we kind of forget that that negative gets applied to both terms in the parentheses, or if there was 3 or 4 terms, it would be applied to all of them. So negative 1 times t is going to give me a negative t. Negative 1 times a negative 9, think of this minus sign as being a negative 9. Negative times negative gives me a positive, so I have a plus 9. Over here, the negative 52 and that minus 8t, there's nothing I can combine there. There's no distributing to do. There's no like term, so I'm just going to rewrite that sloppily as it already was. All right, so now on the left-hand side, I'm going to go back and check and see what can I combine. Oops, first of all, this is 8 16t, not just 16. So I already see I missed a little t in there. So I'm going to call that plus sign a t and make another one. So 8 times 2t was 16t right there. So let's say I've got 16 t's and I'm subtracting a t over here. So I assume that's just minus 1. 16 take away 1, I've got 15t. And then I had just a plain old 8 and a plain old 9. So just constants, 8 plus 9 is 17. So that is 15t plus 17. By the way, if I have a choice, I very rarely use t as a variable because my t's look a lot like plus signs. And that's kind of probably what's tripping me up right now is I think I've made a t and instead it's a plus sign or the other way around. All right, I'm just going to bring this down again, negative 52 minus 8t. So at this point, I've distributed, I've combined like terms, and there's no more simplifying I can do on each side. Now is where I actually start balancing the equation, start moving things from one side to the other. I think I'd like to have my variable on the left-hand side this time. It doesn't really matter, but I think that's what I'm going to do. So whether I actually move the t values or the constants, the 17 and the 52 doesn't really make a difference because it's all just adding or subtracting. But I'm going to deal with the variable first this time. So I don't want any variable on the right-hand side. So I'm going to get rid of that minus 8t by adding 8t. And notice I'm lining it up with the term that it can be canceled with. So to cancel out a negative, I'll do a plus 8t. And since t is here, I'm going to do plus 8t here. All right, on the right-hand side, and negative 8t or minus 8t plus 8t, those are going to cancel. I'm just left with my negative 52. On the right-hand side, 15t plus 8t should be 23t. And I still have the plus 17 from earlier. So at this point, it looks like a two-step equation that we would have done a couple days ago. I still want to get t alone, but at least I only have it on one side of the equation, so that's a good step. So reverse order of operations, so it's being multiplied by 23 and it's having 17 added to it. So with reverse order of operations, I'm going to deal with the adding and subtracting first. To get rid of that plus 17, I'm going to subtract 17. I do it to the left-hand side, I do it to the right-hand side. These are gone. I'm left with just 23t, getting closer to the end. I'd have a negative 52 and subtracting, going even deeper in the hole. So I'm actually adding those. You could think of it as adding a negative 17. And that should give me a negative 69. And now I'm at a one-step equation. Got one thing to do. So right now, t is being multiplied by 23. I'm going to divide by 23 to undo that multiplication. If I do it to the left-hand side, I do it to the right-hand side. 23 divided by 23 is 1. 1t is just t. Negative 69 divided by 23. 23 goes in there 3 times, but since I start with a negative, my answer is still negative. So I have t is equal to a negative 3. So all of that work just to come up with a simple like that. All right, we'll clear that one off and get to number 24. And 24, just kind of, again, adding more little steps as we go through. So before we had distributing, simplifying, we still have all those things, but now we're dealing with more fractions. So it just gets a little bit extra stuff each time we go. So order of operations says I'm going to deal with my groups first. If I could simplify, solve what's in the groups, I would, but I can't. So I'm going to be doing distributing. I'm going to take each of these values times 7 on this side. I'm going to take each of these values times 2/5 on the right-hand side. So this is 6/5 times 7. So if it helps for you to think of this as 7 over 1, just remember you do numerator times numerator, denominator times denominator. So that should give me 42/5 for my first term. And this is a negative b. Or you could think of just as minus a positive b, either way. 7 times b is just minus 7b. Plus 3. So this part I'm just bringing down because I can't actually do anything with it just yet. I'm not really at that point yet. I'm still dealing with my distributing, so I'm just bringing that down. On the right side, 2/5 times b is just 2/5 b. And by the way, the reason these fractions look different where they're not really stacked, you just have that slant, is that's just the way it looks on the computer. And then 2/5 times 5, well, I could think of that as 5 over 1 if that helps. So I'm doing the 2 times 5, 5 times 1, which would give me 10 over 5. But I know that's going to end up being 2, 10 over 5. 10 divided by 5 is 2. So 2/5 of 5 is 2. All right, so at this point, I have done my distributing. Now I'm going to see if there's any like terms I can combine on each side. So it's a little tempting to think, oh, I could do this is 5ths and this is 5ths. I can combine those, but this does not have a b in it, and this does. So even though the fractions look like they would go together nicely, I can't actually combine those because they're not like terms. What I can combine is this negative 7b and this positive 3/5 b, and negative 7 3/5 don't go together as nicely, but they both have the b. So these are the ones that can be combined. So negative 7, and I add a positive 3/5. So I think that's going to leave us with a negative 6 2/5. If you want to do it as improper fraction, that's fine too. If you want to change it to decimal, that would be fine, but this is what I'm using right now. So I'm getting this by combining that negative 7 and that positive 3/5 b. Well, they're both b terms or values. And then the 42/5 I'm just going to bring down. And here again, maybe this would be helpful to make it into a mixed number, but we'll see at the next step. Sometimes it just depends on the problem you're doing. If it's easier to leave it improper as a mixed number. I can't simplify anything on the right-hand side because those are not like terms. So I will just rewrite 2/5 b plus 2. All right, so now it is time to start moving things from side to side, start canceling some things out. I think I'll put my variable on the left-hand side again. It doesn't really matter, but sometimes I'm just kind of in that habit, so that's what I'll do. So I'm going to get rid of this 2/5 b now because I don't want to have a b value on both sides. So to get rid of a positive 2/5 b, I'm getting rid of the whole thing. So I'm just doing minus 2/5 b. If I do it to one side, I do it to the other. So here, these are just going to cancel out. I'm just left with that positive 2. On this side, I was already in the hole, and I'm subtracting, so it's going to go deeper in the hole. So I'm actually adding the two negatives together, which should give me a negative 6 4/5. I had 2/5, another 2/5, all negative, so I'm at negative 4/5. And that b is just still b. You can almost think of that as like the label, just stays with it. And then the 42/5 is going to stay put. At this point, though, as I'm looking at this, I think this might be a little easier if I make that into a mixed number. So 42/5 is a mixed number. 5 goes in there 8 times with 2 extra. So 8 2/5. All right, so now I'm trying to get b by itself. There's a couple things happening to it. We'd assume there's a positive here, so we could think that it's being added, or that 8 2/5 is being added to it, and it's being multiplied by a negative 6 4/5. So reverse order of operations, I'm going to deal with that 8 2/5 first. So I'm going to subtract 8 2/5 from both sides. Do it over here as well. On the left-hand side, I had positive 8 2/5. I just subtracted, those are just gone. I'm at negative 6 4/5 b. On the right-hand side, I had a positive, I subtracted 8 2/5. So let's see, if I subtract the 8, that will get me to a negative 6. And then I'm also subtracting 2/5, so I'm going in the hole another 2/5. So I'm at negative 6 2/5. All right, so at this point, I think it's going to be better if I make these into improper fractions. So 6 4/5, that would be negative 34/5. 6 times 5 is 30 plus 4. On the other side, negative 6 2/5. 6 times 5 is 30 plus the 2. Should give me a negative 32/5. All right, so right now b is being multiplied by a negative 32/5. To undo that, I multiply by its reciprocal. The reciprocal of negative 34/5 is negative 5 34ths. So we just flip it. That's one way to think of that. If I do it to the left-hand side, I'll do it to the right-hand side. Negative 5 34ths. So over here, these 34s will factor out. These 5s will factor out. Negative times negative becomes positive. So I'm left with just one b, which is good. That was the whole point, was to get b by itself. On the other hand, I can do some factoring. 5s can factor out. They both just become 1s. These are both even numbers, so I could divide those both by 2. This should be half of 34 is 17. Half of 32 is 16. And I've got a negative times a negative, so that's going to give me a positive. So I just go straight across. 16 times 1 is 16. 1 times 17 is 17. So in the end, B is equal to 16 17ths. It's getting kind of squished in there, but hopefully you can still make sense of that. So number 24 is 16 17ths. So you're starting to see where all these things that we've been doing kind of start adding up, and this gets to be more and more. All right, moving on. For number 32, this right again. So I need to do 8 times the number. 8 times a number, so 8n. And the number increased by 504. N increased by 504. Put that down there. So the biggest part here is really just knowing how to write the equation, because compared to the last 2 problems we did, from this point, it's pretty simple. I don't want n on both sides. Since there's already not much on the left-hand side, I'll just move this over to the left. So I'm going to subtract an n from both sides. These are gone. 504. Divide. So right now n is being multiplied by 7, divided by 7 on both sides. 7 divided by 7 is just 1. 1n is just n. On the other side, I'm thinking that's going to be 70. Well, we'll take a look. Should be 72, but we can check that. Let's see, 70 would go into 490 70 times, and there'd still be 14 left over. 7 goes in 14 twice. All right, so that one again, is just getting the equation written is their main thing, and at this point, being able to solve it should be fairly simple compared to other problems we're doing. All right, last one. So on these ones, there's like 3 problems in the book like this. They talk about sort of a break-even point where they are comparing the amount that a business or company has to spend on their product or to get started versus what they earn. And there's a lot of startup costs for materials or just renting your space and things like that. So at some point, you have to sell a certain amount of stuff just to break even. And then if you sell beyond that, then you actually start making a profit. And if you sell less than that, you're actually losing money in your business just for the startup costs. So that's what this is representing. Startup costs, and the one on the right is the what you're earning or your revenue. And then it wants to explain what these formulas necessarily represent. But find the break-even point, you basically just take the 2 different formulas and set them equal. You're going to basically do the same thing. You just set one of the equations equal to the other, and then you just do what we've been doing. So going on, once again, we don't want x or your variable on both sides. We just want one or the other. So I'm going to get rid of this one on the right-hand side. I have an x. To get rid of it, I'm just going to subtract an x. If I subtract an x on this side, I'm going to subtract an x on this side. And again, notice I line it up with the term that can actually be subtracted from, because doing x from 22,000, I can't actually do it, so it doesn't really make sense to write it there. These just drop out, and I'm left with 12,000. On the other hand, I've got on this side, I had 14 x's. I took one of them away. I still have 13 x's. All right, so I do not want to have this. So I've got 2 things to get rid of with the x. I've got being multiplied by 13, and from it is being subtracted 22,200. So I'm going to deal with this first. To undo subtracting 22,200, I'm going to add 22,200. So here, they're just going to drop out. Over here, I need to do the same thing. Maybe I need to use this text function a little more often. It looks a lot nicer in my writing. All right, so I've got that. So now on the left-hand side, I've got, only thing left is 13x, and that is equal to, let's see, I've got 22,000 plus 1,200 should give me 23,400. Hopefully that's right. I do a lot of these mentally and I do make mistakes from time to time. So at this point now, I still have this 13. So I'm going to divide by 13. And if I divide one side by 13, I will divide the other side by 13. Put this little guy in there just to show that we are in fact dividing. So what's left on the left-hand side is x, because 13 by 13 just gives me 1x, or just x. On the other one, I've got a little bit more work to do. So let's see, I guess I'll actually set up for long division. Usually try and do these in my head, but I also don't want to get it wrong. Should have been there once. There's 10 left over. 13 should go into there